question. Methanol is going to burn in oxygen to form carbon dioxide and water. Write a balanced equation for the combustion of the liquid methanol and calculate. I believe we have some typo error over here, and actually we are going to ask the delta H of the reaction, delta S of the reaction, and also delta G of the reaction at 25 degrees Celsius. And then we are looking at the combustion of methanol is spontaneous. So we switch gear to looking at thermodynamics. So we are delta G, delta H, delta S, and delta G. And from here, we are looking at 25 degrees Celsius, and we are looking at the standard state. So that's why we have a little circle over here. Okay, so let's do the equation. So to determine the balanced chemical reaction for combustion of methanol and call the value blah blah blah, something like that. Since when the combustion is obviously this our solution is missing the chemical equation, and then also missing a lot of important information. But again, let's complete this solution. Okay, first of all, we have a combustion reaction with methanol. So we have CH3OH with liquid. Okay, so for combustion reaction, we are going to burn our organic compound in oxygen. So we are going to plus oxygen, and then we are going to have only CO2 and also H2O as our product. So this is called combustion reaction. So this is a complete combustion reaction. Okay, so this is the combustion reaction. The next step, we are going to balance the chemical reaction. So on the left, we have one carbon. So we only have to need one carbon. So we have one carbon from CO2. That is fine. And then on the left, we have 4 hydrogens. On the right, we have only have 2 hydrogen. So we have to put 2 in front of water to make sure we have the same number of hydrogen. So we have 4 hydrogens. On the left, we have 4 hydrogens. Okay, so on the right, we have 1, 2, 4 oxygen. On the left, we have 3 oxygen. So we have 2 from here, 2 from carbon dioxide, and then 2 from water. And then on the left, we have 1 from methanol, and then 2 from our oxygen. So we have 3, and we have 3 on the left, 4 on the right. So therefore, we need one more. I would say we need one more on the left. Okay, so we have 4 oxygen, and then we have 3 over here. And then in order to make sure we have 4, so I'm going to use a fraction to make things a little bit easier. So we will have 3 over 2 of oxygen. So at the end, we have 3 plus 1 is 4, and then I'll write it 4, and then we have a balanced chemical reaction. Okay, so for this question, obviously another information missing is that we have to know the delta HF, standard enthalpy change of formation of individual chemical species. Or maybe we have another delta H or delta S, etc. information being given. Okay, so from this case, because from the solution, refer to Appendix 2B. Actually, I don't have the textbook. I don't even know which kind of textbook is that. So I don't know what kind of information they're going to provide you or even provide me the solution. So from here, what I can tell you is that assume the most common way or most common situation that you have when you are looking at this question is that you're given delta HF. What is delta HF? Delta HF is the standard enthalpy change for formation of reaction. So you most of the time will be given at the back on textbook, given on your exam or midterm or some other source of information. Okay, so when you can find all the delta HF from the individual chemical species, and the delta H naught of the reaction, that what we are looking for, will be equals to the sum of the delta HF for our product minus the sum. This is called sigma, just a sum. The or everything, the delta HF of our reactant. So and then you will have your number. Yeah, and then you have a number. And same thing happen. You can find the entropy, of individual chemical species, and the delta S, of course, the center entropy. Again, it's just the sum of the entropy of product minus the sum of the entropy of reactant. Yeah, so I believe those are the information given from the apprentice from the solution. Okay, so yeah, you can find delta H log, delta S log, but for delta G, the free energy change will be equals to the delta H log minus T delta S log over here. So I believe if we have that test book, if we have that apprentice, we will have the value of delta HF. So we just need to apply this equation to solve for that. And then we also have the entropy or individual chemical species. We apply the equation to solve for that. And then we will have the delta S and delta H. And then for temperature, we are going to look at 25 degrees Celsius. But again, we are looking at Kelvin. So we are looking at 298 Kelvin. So when you the next step, you plug in everything, you will have found the delta G log. And this is the answers. I would say this is the general approach to solve this question. But again, this question is just missing a lot of important information. So I cannot even go through the calculation with you. But this is the strategy that we are going to use to solve for this question. Alright, so the solution is incomplete. I think I spelled wrong. So information amazing. Please revise the solution. Okay, so I'll give it incorrect.